so in this video we're going to describe what is a graph, right? What makes up a graph? How do we describe graphs, right? So a graph, just in general, all right, so when we talk about graphs here in discrete math, what we're talking about is a graph that consists of a set of vertices, right, which we can label, which can be just abstractly just numbers, right? And these, or we can name them like in terms of some kind of objects to be more descriptive of what we may try to model, right? So for instance, here we could say, all right, 1, 2, 3, 4, 5, 6. So that's one part of it, right? And then connected with what we call edges, and those edges describe the relationship, right? So let's say that I have this set V, right, and the edges I want to correspond to the numbers that add up to 7, right? So that would be the edge 1, 6, 5, 2, 4, 3, right? So we could see that looks like this, right? All right, and then again, this is one type of graph, right, that is related in this way, right? That's what those edges represent. And again, we can always define how those are related, right? So if we have, let's say instead I want the graph, right? Same V, right? I labeled the vertices the same, right? But let's say in this case, I'm looking for the sum being, so the sum is even, right? So that happens when I add either two even numbers or two odd numbers. Okay, so we can describe a graph like this, right? Now, this is an example of a simple graph in the sense that um, the relationships are symmetric, right? So the edge from 2 to 4 is the same as for 4 to 2, right? In certain cases, maybe we want to distinguish in what direction it's going, right? But for simple graphs, right, we just look at symmetric relationships. 2 to 4 is the same as 4 to 2. And we don't necessarily have nodes related to themselves. In other words, there's no loops, right? We don't allow for that, right? Which again, depending on what you're modeling, may be something you might want to do here. But here for simple graphs, we just look at the graphs being symmetric, right? 2 to 4, the same as 4 to 2, all right? And there's no relation to itself, right? So it's not, I can't have like a loop going from starting at 2 and ending at 2. Okay, now in terms of terminology, right, if something is connected by an edge, then so if two vertices by an edge, then we say they are adjacent. Right. So here is an example here, right? So again, this comes up with how we can represent a graph, right? Let's look at a different graph, right? Let's say G, graph G, and we have vertices V1, V2, V3, and V4, right? And the graph looks something like this. Okay, so visually we can represent a graph like this, and we can also have a kind of chart where we have the vertex and then adjacent to, right? So we have four vertex here. All right, so V1 is adjacent or connected to V3 and V4. V2 is connected or adjacent to V4 and V3. V3 connected to V1, V2 here, and then V4 is adjacent to V1 and V2. V4 is V2, V1, V3, V2, V1. Okay. Okay. All right. So that's another way to represent the graph, right? So not necessarily, we don't really need the picture. The picture's there as a nice visualization here. So let's get into the definition, and we'll see the definition, right, is a set forward definition, right? So it just defines a graph as a set, right? Unordered pair of sets. So here, let me write that out. So we're gonna define here, right, a graph is an ordered pair, which we say G, V, E, consisting of a non-empty set V, which are the vertices, and a set E, which represent the edges of two element subsets of V. Okay. All right. So again, right, let's pick out the kind of details here, right? I think the vertices is straightforward, right? So if we look at our graph G up here, right? So looking at that here in this definition, right? So if we want to define G as this ordered pair VE, oops. So it's two sets, right? So the V is the straightforward one, right? I just list the the vertices, all right? Now this set E, all right, it's a set of sets, right? And each set consists of two elements, all right? So for E, right, the set is going to consist here of the adjacent uh, vertices, right? So here, for instance, V1, right, adjacent to V3, V1, V4. Right, symmetric, so I don't distinguish, and it's a set, right? So the order doesn't matter. V1 the same as V1, V3, the same as V3, V1. All right, so I captured that, and then we also have from V3 to V2. And then lastly from V4 to V2. Okay, so now we see what the set V, an example of what the set V and what the set E looks like here. Okay, where V is just the vertices and E is a set of sets, right? And each set in E consists of two elements. All right, so that's how we are describing graphs. Again, as you'll notice here, in general, right, this course here, there's a lot of vocab, right? So important to take some time and be comfortable with the vocab, understand what these definitions mean when I talk about a vertex, an edge, what does it mean to be adjacent, right? Things like that. Okay, so